Alright, we're recording? Okay, so back to the start. This is take 3, Jason's shower loop. Should be excited. So, we're here to save beautiful, yummy hot water. um, so, yeah, normal showers, the water, it touches your body for a few seconds, rolls off you, and it goes down the drain. And that water's most of the time it's pretty clean and it's full of energy. And we're here to save a lot of water and energy by using Showerloop. Showerloop collects the water in the drain and then pumps it through a bunch of filters, sand, activated carbon, microfiber and ultraviolet light, and that cleans the water of um, all its impurities and bacteria and everything, and then it goes on your body again, and it just it loops around for as long as you're in the shower. And here's like a little kind of schematic of the shower. On the left, on the very bottom, you see the collection basin and then the pump, and then it goes up to that yellow thing, which is the sand bag, and then above that there's the activated carbon bag, and then it flows into the UVIR, the ultraviolet radiation reactor. That's kind of the technical name for it. It's not a filter; it's a purifier. And then that's what destroys the germs, and then it goes into the shower head. On the right, there's these different. Uh, there's a bunch of valves and different modes. So shower magic, bypass, and backwash. And shower magic is the looping mode. So the water goes through the pump into the filter, through the filter, and up to the shower head. And then there's bypass mode, which is for if you're really dirty or something and you don't want to use the filter, you don't want to wear out the filter, say for whatever reason, then you can bypass it, and it should work like a normal shower. Um, Not that you'd want to do that very often. And then there's backwash mode, which then cleans the filter at the end of the shower. So the valves are electronically controlled by Arduino and things, and they're generally quite cheap. Music's really picking up in the background. I hope it's okay. Here's just a bunch of pictures and diagrams from our experiments. We did a bachelor's thesis on the topic and tested it for microbes and nitrates and suspended solids and dirt and everything, and we optimized the size of the filters so they're as small as possible but also as efficient as possible, working to provide totally clean water. So it's good enough to drink. Here's a bunch of pictures of our different prototypes that we've had. Always like lots of dangly cables and cords and things. Um, this might be the point when you ask why is there a bunch of electronics or something in the shower? Why can't you just use the pump? And the reason for that is one, I want it to be kind of cool. Two, it should be automated so you don't have to, like for instance, washing the filter. Do you want to be cleaning your shower after you had a shower? That's not cool. And then also, we have sensors in the shower that then can show you temperature and water pressure and things like that. Things that we don't really have any kind of measurement for. You don't really know how to estimate how much water's going through at any given moment, and so like education, biofeedback is a really important component of it. And then like in the middle there's like LED lights and stuff, so it's open the possibility to make the shower really a more physical virtual reality kind of experience. Oh no, I'm just like rambling, aren't I? Anyway, um, here's the super effectiveness of Showerloop compared to a normal shower. Here's another way to look at it. Energy and water saved in comparison over time. The longer you're in there, the the greater the efficiency of the shower. Um, for an average 10-minute shower that uses 100 liters and has water that's about 40 degrees warm, Showerloop uses 90% less water, 70% less energy, basically 90% cheaper per shower, better quality water, and it's stable water pressure and temperature. In Finland, the cost of Showerloop is 20 euros a year, while a normal shower costs about 200. And in Denmark, it's quite a lot more. So your savings in Denmark would be way more than your savings in Finland. I tried to look it up for Belgium, but couldn't find it. Kind of annoying websites. So the cost is around 1,200, maybe 1,500. Really depends on a lot of factors. The main one right now is that we want to reduce the price of a certain component, which is actually half. It costs 700 euros, and we think we can drop that price down. So that's kind of maybe our profit margin. The lower we can drop that price, then um, maybe we'll get more profit. I don't know why I'm talking about that. Anyway, this is a good deal for anybody. Return on investment 6 years for one person, less than 2 years for a family of four. If you take really long showers, it can be 1 year return on investment for a single person, especially in Denmark. For a single person, it's like a bit over 2 years, and that's if you only take 10-minute showers. Why not enjoy yourself now that you can? Uh, we wanna we want to sell kits. We want to release the plans for free for everybody, and you can go out and make your own shower. You can modify it. I guess you can sell them too. But most people aren't going to do that, and there is seriously a lot of work involved in trying to find out where you can get things from if you're not like doing this all the time. We can give you all the parts that you need for like the basic kind of shower, but then if you need something in particular, you want tiles on the floor, or you want a plastic floor or something, a specific size plans, then we can help you with that. And so open source, open hardware, we can sell our services. Here's a view of the shower being assembled. This is with the older components. We're remaking everything now with like CNC machines and laser cutters, so they'll be like really pretty. This is still a bit prototypey, but it works. Our competition, they're more expensive. Um, we're the best. Um, uh, the return on the return on investment for a solar panel is maybe 15 years, and pretty much the same for wind. So Showerloop beats that, and it also reduces your home's energy demand, and that's really valuable because if you reduce your total energy usage, then when you go renewables, you don't need to buy so much. You can buy less. Like you can buy only one solar panel instead of 10 solar panels to run your shower, for instance. So that's really good. Um, our efficiency would totally beat anything that's standardized, categorized on. So That's yeah. You can make your own conclusions. In the middle, there's the Finnish nature conservation logo, which represents us building it in Finland. Of course, it'd be really great if we could have um, Showerloop kind of maker spaces or assembly points all around the world that then where you could go and build your shower, for instance, or get the kit and they've sourced local materials as much as possible. So if there's a pump manufacturer right down the road, then the pump is from there. Or the walls are made out of bamboo or something if that's available near you. Um, everything's replaceable, recyclable. We'd just increase the cradle to cradleness of the product as it goes along. We want to sell kits online. We want to crowdfund, invest. We want to develop the shower with the community, ideally, and drive the price down so that we can help as many people as possible. If we can really, really get the price really low, then we'd be in a huge position to help refugee camps and slums and stuff like that. Here are the guys, our MVPs, Anu, Patricia, Kieran, Edu, and myself. If you have questions, contact me. Alright, alright, alright. Done.